Hi students, how are you all? Yes, today we are going to see the another family oxen. See, oxen family also called salcogens. It is also called salcogens. See, what do you mean salcogens? Salt producer or ore producer, not salt, ore producer, ore producing compound. That's why they are called Salcogen family. See, in this family we have oxen, sulfur, selenium, tellurium. The last one is polonium. See, these are the compounds. Sorry, these are the elements are present in this family. Very important first two elements, because compared with the others they are only less amount present as a sulfide. So here we are going to concentrate these two elements in this family, right? As you know very well how much important that oxygen, right? We cannot live without oxygen, we know very well, right? So oxygen and sulfur we are going to discuss in this video. First, what's the group number? Group number 16. This family top we have oxen, so we can call it oxen family also, right? Then what is the percentage of oxen they exist? See, the first place occupied by the most abundant element, that is nothing but oxygen, the most abundant element. So which one of the element is most abundant in earth means we can say oxygen, right? Followed by, we can see the percentage of oxygen in the atmosphere. See, 20% we know that the atmosphere, 20% as well as weight and volume. See, if you compare with the volume wise 20%, if you make it a comparison with the weight, that is also 20% present in the atmosphere. Then if you see in the earth crust, this is in the atmosphere. Now in earth crust also 46.6% we have oxygen, only 0.134 present sulfur. Am I right? 0.034 present sulfur as a oxide. Sulfur may be present as a gypsum or a Epsom. Gypsum like Epsoms, it may present sulfur sulfate as a sulfate, calcium sulfate like that. Oxide means it may present galena, zinc, sulfide, Z like sulfide also present. So simultaneously we are discussing oxygen as well sulfur. Now if you compare that sulfur also present in volcanic ashes, in the volcanoes it's giving more ash, that volcanoes ash also having more amount of sulfur. Then elements, other elements in this group not much abundant, so they are present as a sulfide somewhere. Then physical property, if you compare, except oxygen all other solid, oxygen gaseous element. Now specifically we are going to discuss about oxygen. See, oxygen, how much percentage present in the atmosphere? Sorry, present in air. That means atmosphere, both are correct. 23%. Okay, out of 23% we have air as a oxygen. Then in water, H2O, we can remember this oxygen we have nearly 83% in the seawater. See, we know that 3% of the earth covered with what? Water. See, 83% of water also having oxygen. Then we can see that maximum rocks made up of oxides compound, okay, like zinc sulfide, magnesium oxide, like oxides of elements only making as a rock, made up of rock. Then how we prepare oxygen in industrial purpose or in laboratory? By taking the peroxide or decomposition of a metal oxide. So first we are going to take decomposition of hydrogen peroxide, H2O2 two times in the presence of a MnO2 catalyst. It will form H2O plus O2, right? So MnO4, if you take, it will convert into 4 plus 2, 2 plus. Okay, right? Then how you prepare other type means by taking the metal oxides. First mercuric oxide, on decomposition it may give mercury with oxygen. Okay. Then barium oxide, it may decompose into barium oxide with oxygen. Okay. Now it may from oxyacid. Oxyacid means what? Potassium chlorate or potassium nitrate. So KCl3, potassium chloride, is on decomposition. It will produce 3 moles of oxygen. As well, potassium nitrate, KNO3, it may give 2KNO2 plus O2. So like we may prepare oxygen from all metal oxides and oxyacids. Then properties of oxygen, how it is reacting like that. See, we know that which is exists as a diatomic or dioxin gas. You can say dioxin gas. That is nothing but O2. Okay. They are paramagnetic. We know the diamagnetic, paramagnetic. It is paramagnetic. We may study in molecular orbital theory, MO theory. Then, if you compare like nitrogen, fluorine, oxygen also more electronegative. So they are forming hydrogen bond. Okay, very important. Then we are going to discuss little about ozone. So oxygen is existing two allotropy form. One is dioxin and one is ozone form, O3, right? So O3 is present in the above seawater. Seawater only we can see some amount of ozone, not much we can see. And also see which is made up of, how it is produced means because of in higher atmosphere, that means in that high altitude, that ultraviolet rays, UV rays only makes the oxygen into ozone. Then we can prepare artificially in our laboratory also by passing electric discharge, by electric current. Nearly how much? 20,000 volt. At if you pass current, am I right? Yes, 20,000 volt. You can have only 10% of ozone from oxygen. Okay, so O2 will form ozone. Only 10% can convert into ozone. See how much temperature we are using. Let us see the equation. O2, it may undergoing decomposition. It will form nascent oxygen. Then O2 with nascent oxygen will produce ozone, O3. Am I right? Yes. After getting that, it becoming blue color gas, right? So it becoming blue gas. We can separate by fractional distillation method. What method we should take? Fractional distillation. By using that method, we can separate this gas as a form of liquefied gas. We can convert into liquid. So liquefied gas we can separate out. Okay. Here one more thing. The structure of ozone O3 may present two canonical form because of resonance structure. See, it may have one lone pair electron, one side oxygen having double bond, one side single bond, all of 6 lone pair electrons are present as well minus. Suppose it is forming double bond, it will form minus. Then here we will get, see, lone pair electron also we must write 1, 2, 3, 4, 5, 6. Sorry, we don't have 6 double bond. So this like two canonical structure it will form. Then chemical properties of oxygen and ozone if you compare, which have vastly different from oxygen and ozone, right? See, easily we know that oxygen, it is more reactive. It can form several compounds with several metals, right? And as well as non-metals. It will react with metals as well as non-metals. Okay. Suppose we have less reactive metals, we can make it into powder. The powder form acting as a exothermic reaction. If you treat with the powder form of some low reactive metal, it is producing heat and forming some compound. But many compounds are not easily reacted at room temperature. But if you take in the side of ozone, which is not easily reacted with any other metals, but it can act as an oxidizing agent. It can act as an oxidizing agent. Okay. See, some metals we are using finally divide into powder, you know, they are called pyroboric. That name we must know, pyroboric metals. Now we can see how the ozone acting as an oxidizing agent. With potassium iodide, if you take ozone along with some amount of water, now it will produce iodine gas along with our oxygen gas. Okay, so now if you see here -1, it is oxidized into 0. That's why we are telling oxygen is an oxidizing agent. Now we will see importance or uses of oxygen. We know very well which is need for all living things. Then we can use it in welding. Particularly they are telling oxyacetylene welding. Okay. Then liquid oxygen is used as a fuel for rockets. Then we are going to discuss about sulfur. See, sulfur also having some allotropic forms. One is crystalline form, another one is amorphous. Amorphous means like powder. Okay. That crystalline, again, we can divide based on their structure. What is that? Rhombic sulfur. It is also called alpha sulfur. Then another one is monoclinic. Different structure, different type of structure we may study in solid state. Are you able to remember? Yes. So rhombic, monoclinic structure. Then amorphous solid, amorphous sulfur also having some divisions. What are they? One is plastic sulfur. It is also called gamma sulfur. Then milk of sulfur. Milk of sulfur. The last one is colloidal sulfur. Okay. Particularly we are going to discuss these two, rhombic and monoclinic now. See, first we are going to learn about rhombic sulfur. In this sulfur also called alpha sulfur. See, only it is stable at thermodynamically at room temperature. Based on the temperature, we can able to stabilize, which is forming yellow color. What's the color of this alpha sulfur? Yellow color. See, it is forming like S8 molecule. Like we will see ground structure, as well as we will see some other structure. Okay, it will come one more. This structure only called the ground structure of S8. We will see later. Okay, then if you heat slowly at 96 degrees Celsius, it may converted into monoclinic structure, right? Then if you cool again, we can get again alpha sulfur, that is rhombic sulfur. Yes, but here we must know that if you use some monoclinic sulfur, that monoclinic sulfur also exists S8 as well as S6. See, only rhombic sulfur forming S8 molecule. Normally, some amount of monoclinic sulfur also exists in S8 molecule as well as S6 molecules. Okay. If you see that structure of this S8, S6, it is forming like needle structure. Needle-like structure they are forming. Okay. This needle-like structure is called prismatic structure. Needle-like prism they are forming like structure. They are called prismatic structure. Prismatic structure. This may you can have a 1 mark, so please underline your book. If you want to get this prismatic structure, you have to maintain the temperature 96 to 119. The temperature, if you maintain, you can get this needle-like prismatic structure. Then we can interconvert. Within this ratio, we can interconvert rhombic to monoclinic structure. We can interconvert. Then we are going to see some unique character of sulfur. What is that? See, if you poured into molten means liquid sulfur, if you poured into cold water, you will get plastic sulfur. Okay. See the yellow color, rubbery, like plastic, not plastic, rubbery. Yellow color, rubbery sulfur will get. If you pull it again it becoming like a tensile. If you pull it for long time, it becoming hardened. Okay. The last, we are going to discuss about some percentage of sulfur. See, maximum sulfur exists as a liquid and gaseous state around 140 degree. What will happen? The monoclinic sulfur metal melts to form mobile pale yellow color. So it will melt. Which one? Monoclinic sulfur will melt at 140 degrees Celsius. It will melt. It becoming liquid as a pale yellow liquid. It is called lambda sulfur. The liquid form sulfur is called lambda sulfur. Then the vapor over the liquid sulfur consists of, see here liquid we formed, some vapor may present. It may have S8 or S6 molecules. Okay. S7 also. S6, 7, 8 molecules present as a vapor. Then small amount we may have along with that S2, S3 as well as S4, S5. So from S2 to S7 we have, but more amount we have S8, S7, S6, less amount S2, S3, S4 and S5. Okay. Then some sulfur dioxide compounds we will prepare, that we will see in the next video. Thank you.